Hi, I'm Paul Brodie. Welcome to my shop. Mitch is behind the camera. I'm over here. So my shop has been different things at different times. For a long time it was an Aramaki shop, and then it became an Excelsior shop, and right now it's a Tiger Cub shop. So we're working on Tiger Cubs, and I had a plan today to work on the swing arm because I got the bushings in. We're going to talk about the bushings a little bit, and then I ordered a Reamer on Thursday, and the company said, okay, we'll order it first thing Friday, you'll have it Monday because it always comes there. And then I phoned up yesterday because today's Tuesday, filming day, and they said, oh, it always comes there, but for some reason they sent it ground. I have no idea why, sorry. So had a plan to ream out the bushings, and that's not going to happen, so we have to go to plan B here. I thought that I was going to make some bushings because it used to be years ago that I'd just go to a metal shop and I'd order bronze. I'd get a tube. I mean, this is all leftover stuff from years ago. Now I go to the metalwork at the metal shop, and they don't have this anymore. They've got very little stock. So the situation with the machine shops fixing stuff, putting in bushings, that's kind of like a thing of the past. And the bronze is really expensive. So he says, why don't you go to Wajax and just buy some bushings? So that's what I did. I went to Wajax, ordered the bushings, and they are oilite bushings. Oilite is not like bronze, and I'll just explain the difference a little bit, and it's good to know. This is 660 bronze, and it machines really nicely, and then after you have the bushing, you can hone it or you can ream it. You can do either. So oilite is made, I think they started making it back in the 50s or something like that, and it's made out of sintered bronze, which is a powdered bronze. I don't know exactly how the process works, but it's made under probably heat and force, and they make the bushings. But inside the bushing, the actual bushing is like a sponge. And I was reading that that's how the bushing is self-lubricating, because it's 18%. You can put 18% oil into the bushing, and they do that with a vacuum process. So the oil is in the bushing. So if it's in some place in a machine that's hard to get to, it's a perfect situation in a way because it's always lubricating itself. So I'm going to show you, Mitch has the images, he's going to flash them up, and I'll show you what happened putting in the bushings, okay? Okay, so here's all the pieces. We got the swing arm, we got a good axle, a used axle, and the bushings they sold me were too long. I asked for 1 inch long and they came 1.25 inches, but I've got a lathe, so I took off 1/4 of an inch, made them the right size. This is installing them in the press, the arbor press. You see how it's supported here? I don't want to support it at the bottom. I want to support it right under the casting where the bushing is going into. That's the correct way to do it. This is the interesting part. This is the first one I pushed in. Can you see how much oil has seeped out here? And all I did was to press in the bushing. And then on the second one, look how much oil came out. So these are pretty neat. So what that means is that on these bushings, you can't hone them because it's really soft, and all the abrasiveness of the hone will get in there, and then all that abrasive will go onto the shaft. So you don't do that. And you also have to have, if you are going to ream them, which I have to do, you need a really sharp reamer, because a dull reamer sort of squashes the metal and closes up the pores. So you need a sharp reamer. So this is an adjustable reamer, and this is basically what I ordered. I've got 5 of these and they're all the wrong size. So when I buy a reamer, basically it's from here to here, and then I take a piece of inch cold roll, I bore it out, I weld this on, I put a handle on. What I have to do on the new reamer as well is to drill a hole here and put a pilot out here and then have a tapered cone so that when I'm reaming it, the pilot and the cone wedges into this side and it keeps everything in line. I measured how much metal has to come out. One side is 5 thou, the other side is 7 thou. So anyway, I thought we were reaming today, but we're not. So let's walk around and I'll show you what's new. This is the frame that all got painted. All of those ugly welds, they're all gone. Someone welded on a sidecar mount here on both sides, and then later on someone took a hacksaw and hacked it all off and left what was left. So anyway, I think it's going to be a fine frame, and I'm really happy we're at this stage right now. Over here, everything else is painted. The last thing to be painted is the swing arm, and I can't paint the swing arm until I hone because I need to hold it in a vise or something like that. It'd be silly to spray paint the swing arm and then hurt the paint while I'm reaming because it's going to take some force. Oil tank's done. It's got a decal on it. It got clear coated over the decal. So yeah, it's coming along. I've got the headset cups that go into the frame, and this is the crown race that fits onto the steer column. I've checked the size, and it's not a great fit. It's a little bit on the loose side, so we're going to use some Loctite. It's a retaining compound. It's a green Loctite, and it's an older bottle, so the cap is a little bit plugged up. So what I do is I take a welding rod, brazing rod. There's a little bit left in the bottom. There, oh, there's lots. See that? See how it's green? It's kind of sticky. So I'm going to put some of this around on the race. There we go. And then that's going to hold it on there. And I know on the frame that the lower headset, it came out pretty easy, so I'll do the same thing there. So we have to hammer this down somehow, so I found a tube. So this is known as a, see how it fits? It's quite a nice fit. This is what I call a slide hammer. If you try and use a punch on either side, that might work, but this is way better. See how it goes on? See that? That's not a whole lot of a press fit. It's a little bit of a press fit, almost size on size, but that's glued on now basically. Once it dries, that's glued on. Okay, we're going to do the same thing on the frame, but we're going to install these in the press. I'll just put a little bit around there. Yeah, see how it goes in pretty. That didn't take a lot of press fit, so I'm glad that I have Loctite. And this one should have a little bit more of a press fit, because this one has to be hammered out a little bit harder. If you move it around a little bit, it helps to center it. Oh, okay, that one went into. Not the best press fit, but it's in there. I'd like to thank you for the coffees. Mitch and I appreciate it very much. We have to take out the fork seals. So these are called the sleeve nuts. These go on the forks like so, and the booties go over here. I've got one out, and I tried to order a seal from my local Wajax. It's an odd size. Anyway, the seal has to come out. I know you can buy these out of England, and they sell this sleeve nut with the seal already installed. So I think I have to order the oil seals out of the UK. So see this seal? I got to get in there Oh, look at that. It's just, wow. Okay, let me grab some pliers. That's coming out way too easy. There's an oil seal. Can you see what's left? It's the carcass of steel. That's where we have to grind through, right there. I've got a drift and it's been sharpened up on the end a little bit, so if I can catch each of these, and hopefully it's weak enough now that... Oh, it's moving, yeah, there we go. Can you see it moving? There we go. Okay, that's a success story. I weakened it, and then that takes off the pressure. Well, the pressure is less, and then you knock it out. Here's the first one I took out. You can see how I ground almost all the way through, and then so it popped out. So need a couple seals. Okay, one more thing off my list. So I don't know if this is going to work. We'll find out. Sooner or later I have to start working on the motor, I know that, and there have been a couple comments saying, oh, you're leaving the motor till last, are you? Well, that's just kind of how it worked out, because I wanted to get the painting done because we're almost at winter here and I don't have a huge heater in my shop, so I had to get the painting done while it was still reasonably warm outside. So this is the cylinder that came off the Cub. And the first thing I want to say is that I have a wanted sign. I'm looking for a square head and barrel. So on the Cubs, they came in, I was reading in the Bible, this is the Tiger Cub Bible. They were made in different shapes over the years, and the first ones were round. Then we went to oval. I think this might be oval, but it's kind of hard to know. And then it went to square. So the ones which were square, they were larger, and maybe the barrel was alloy. I couldn't find any real information. So Mitch is going to show you a few photos, 3 actually. I went through the Tiger Cub Bible last night looking at every cylinder and cylinder head. And it seems like what they call the square ones are larger, especially the cylinder head. But I don't actually see square. I didn't see square anywhere. If you have head in the barrel, because I haven't really started on either, I'd be very interested in buying them. So this is one of the racing ones, and it kind of looks like the barrel is larger than what I have there. See how the head really, it comes out from the barrel? So this is what I'm basically looking for, because mine, okay, this is what I have. Can you see how it's the same size? Can you see this one here, how it sticks way out? And then on the last one, this is off some sort of a competition trials bike, and it looks like the head is larger as well. So that's what I'm looking for, something with more fins. I know they're around, so maybe you can help me. I remember when I was taking apart the motor and we filmed all of the disassembly, and I noticed that the main bearings were metric. And 1 or 2 viewers said, no way are they metric. It's an English bike. They can't be metric. Well, they are metric. And then when I was looking at the bore and stroke yesterday for the Tiger Cub, 63 by 64 millimeters. So isn't that interesting that an English manufacturer would choose a metric size for both the bore and the stroke? So 63 millimeters is 2.480. So I need to hone this out. I need to see what size this is after all the scores have come out. So I have a hone, and I'm making this because I didn't have something which went on my honing machine. So this piece here, can you see this end piece here? It started like this. So what I've done is to modify. So I've got more photos that we're going to show you because Mitch isn't always around when I'm doing stuff. So I'm going to show you the process of making this into this. Those are all the pieces that I started with. So I took a piece of steel. It was a 3/8 piece of flat bar, and I machined it down so I could just press it in with a little bit of force. So that goes into there. And then I put it in the lathe, and then I drill the hole because now I have a center. So I took a piece of 1¼ cold rolled, and there's a roll pin. Remember roll pins from other episodes? So I put that together in the vise. I put this piece onto that piece with the vise. It held it, and then I welded it. Nice little TIG weld. So now I mounted it on there. Then I drilled 2 more 3/16 holes, and I used a couple more roll pins so that this is firmly attached onto this. Then I put it back in the lathe and I bored out this so that it would fit the end of the hone. After I left high school, I worked in an automotive machine shop, and this is basically, I was the guy working on motors and doing valve jobs and things like that. So I did quite a bit of honing when I was younger. So you've got these shoes that go in. These are the guide blocks. They're called the guide blocks. And then these are the actual stones. So can you see how it all fits together? So everything's loose right now. So that's where this comes in. It's a spline. And it fits in. And you see what happens? I can make it whatever size I want. Can you see the space there? Can you see how the space is growing? And this puts pressure on, and then it hones. So, the problem I have here now, if I measure this, it's 2.6. And can you see how it almost fits, but it doesn't quite fit. So, these need to be smaller, and I got friends who have hones and all that, and I phoned them up, and nobody has a set of stones and wipers for my hone that are the right size. So what we're going to do, I don't know if this is going to work. This is an experiment. I haven't used this hone for at least 15 years, so it's not like I use it every day. So we're going to hold this in the mill. We're going to mill off, I don't know, 1/16 of an inch, something like that. And then we're going to go outside on the grinding wheel and we're going to grind. I know some people are going to roll their eyes, but we're going to grind the stone with a grinder outside, because you can't machine a stone on the mill. Well, maybe you could. There wouldn't be much left of the bit, even if it's carbide. So let's do that. Let's get this to fit in there, and then we also, if that works, then we have to make up a holder. There has to be something here, because when the stone is going around and there's oil, I can't hold on to this probably. So we need something that goes into 2 holes. There's going to be a loop and a bar, and that rests on the bar in the honing machine. So if you haven't seen this done before, I'm not saying it's going to work, but at least you'll see the process. Okay, let's see how this fits now, because this should just fit nicely. There we go, look at that. So see, there's a little bit of play there. Okay, we're going to go with that. So next thing to do, we have to make a holder here. So there's going to be a couple pegs that go down into there. There's going to be a U-shaped piece. It's going to get TIG welded. And then there's going to be arm that comes off there. And you'll see how that works on the horning machine. That's what the arm, that piece that comes out there rests on the arm. So I don't have to hold the cylinder from turning if it grabs. Something like that. See how it's got a bit of a twist to it? It's pretty close. See these guys? They're going to go down like that. And then this piece is going to get welded onto both of them. Oh, look at that. It's pretty good. This is hacksaw cuts. So, we're going to need some kind of a fixture to hold this, aren't we? Yes. Oh, let's just use the cylinder barrel. How about that? That'll work. Look at that. There we go. Special tool number 63B. Let's see if it still fits. Because all the welding's going to pull it a bit. Not bad. So you see this? This is what this is going to rest on. So this is the oil feed. So you obviously, the stones need oil on them, and it's hard to get the oil in when it's got some length to it. So we'll just put some oil in right now. That's why I got the gloves on. You get oily doing this. I have no idea if the stones are anywhere near parallel. So this is where I have to open up the stones, little by little. So what we're doing here, once again, is we're just running the hone through so that it cleans up. There's no more scores, and then I can measure, see what oversized piston I need. That's what we're doing. Okay, so let's have a little look. It's actually not that bad. See, can you see the lines? Can you see those score lines there? It's not that deep, but so what we'll do is we'll put this round the other way, and we'll do a little honing, and then we're going to wash it with some solvent and check the size. So. And going in that motion of back and forth, that's what makes the crosshatch inside the cylinder. So as you pull it out, you have to be careful not to make lines. So there, let's go out and use the solvent, wash it off, and then we'll do some measuring. Okay, when I'm honing, I'm using a honing oil. It's not a cutting oil, it's not a lubricating oil, it's a honing oil. It's a specific oil for honing which they use in shops. So just so you realize, it's not a cutting oil or anything like that. Okay, what I have here, this is a set of telescoping, no, inside mics. That's what it is. It's not a telescoping gauge. So this does a 2 up to 2.5, and then if you want to measure from 2.5 up to 3, this is a 1/2 inch extension here. So you put in the 1/2 inch extension. So let's do some measuring. Look, I got these used from a guy. They were purchased in 1984, and they were $82 for the whole set. I bet they're more now. You normally measure across, and then you measure this to make sure that it's round. You see how I can just push it through? Yeah. So it holds by itself, but then I just push it through. So it's a fine touch, and I want to get that same kind of a feel. See how it's just touching, but doesn't take a lot of pressure. How you read a micrometer, you got the big line there, that's a 5, and then you got a couple more lines there, so that's going to be 502.5 because it's not at 503. So the size right there is 2.5025. That's how you write that, like that. And then we'll measure the bottom. There we go. Basically almost 2.502. So that's the top, and the bottom is 2.502. So oversize, if you add on 10 thou, you're 490. Add on 20 thou, you're 2.500. What we need in a piston is 030, a 30 thou over piston, and then this will get honed out to 2.510. So that means 2.510. That's the bore. So we would need to hone out almost 8 thou. Make sense, Mitch? Yes. Mitch is nodding his head. I know you can't see, but he's nodding his head. So we are in agreement. So can you see there? There's a little score going down there. It's not huge. So when we take out 8 thou, 7 thou, that's going to go away. If there was a really big scrape, you would see it. There's a little bit of a scrape there, not much. So basically this is in okay shape. Unless I find a square one, that'd be cool. Thank you very much for hanging out with us in the shop. It's been a pleasure. Mitch and I like coffee. If you buy us some coffees, that would be fantastic. See you next week. Take care. See that Allen screw there? That Allen screw is supposed to bite down into there, but it's biting right there. So maybe if I pull it out a little bit, then it'll still turn. Like if I go there, because it really doesn't matter. I just need this to turn. We're winging it. That's what we're doing right now.